Let's get real. Computer engineering is like being a modern blacksmith, forging the future with digital tools. It's about shaping the world around us, not with iron and fire, but with ingenuity and innovation. But your tools aren't hammers and tongs, they are silicon and code. You'll be wielding the power of programming languages and integrated circuits to craft solutions to tomorrow's challenges. You're the architect, the bridge builder, connecting the physical and digital worlds, creating seamless interactions between humans and machines. It's about designing systems that are both functional and elegant. Building the brains inside everything, from the simplest of devices like smart toasters, to the most complex like the guidance systems of rockets that propel us into space. That phone in your pocket, a portal to the world, your car's advanced safety systems that keep you secure on the road, even the intricate network of the power grid. Computer engineers are the unsung heroes who make it all work, ensuring our modern lives run smoothly. We invent groundbreaking technologies, build robust systems, rigorously test their limits, and sometimes, yes, we even break things in the pursuit of making them exponentially better. It's a mindset, a relentless drive to break down complex problems into manageable pieces, constantly chasing the exhilarating thrill of making something entirely new actually work. So if you love tinkering with gadgets and have a knack for solving intricate puzzles, this field is undoubtedly your playground. Computer engineering seamlessly fuses the rigor of science, the precision of math, and the boundless potential of human creativity. It's the art of turning seemingly impossible sci-fi concepts into tangible, groundbreaking realities. You're not just passively using technology, you're actively building the future, brick by digital brick, one line of elegant code at a time. Computer engineering is a tag team match, a dynamic partnership where different skills come together to create something amazing. It's the interplay between hardware and software. These two elements are the fundamental building blocks of all modern computing systems. Hardware is the body, the physical components that you can see and touch. It's the chips, boards, wires, and all the other tangible parts that make up a computer system. Hardware engineers design these intricate systems, carefully planning the layout and connections of each component. They are constantly striving to improve performance, making them faster and more efficient. Software is the mind, the set of instructions that tells the hardware what to do. It encompasses code, algorithms, operating systems, and all the applications that run on a computer. Software engineers write the instructions, crafting the logic and functionality that drives the hardware. They create the programs that bring hardware to life, enabling it to perform complex tasks. But the real magic? Where does the true innovation lie? It's when computer engineers bridge both worlds, understanding the intricate relationship between hardware and software. They know how code changes voltage on a chip, influencing its behavior and performance. They also understand how hardware limits software performance, identifying bottlenecks and optimizing code for specific architectures. This integrated knowledge is their superpower, allowing them to create truly innovative and efficient systems. In the lab, you'll get hands-on experience with both hardware and software, learning how to design, build, and test your own systems. You'll build, test, debug, and push your creations to the limit, exploring the boundaries of what's possible. It's a cycle of experimenting, failing, learning, and rebuilding, constantly refining your designs based on your experiences. The result? Technology that works seamlessly, providing a smooth and efficient user experience. Once you've mastered the basics, you can specialize. Embedded systems are the hidden brains in everything from microwaves to drones. Small, smart, and efficient. Network engineers build the digital highways connecting the world, solving puzzles of speed and security. Security engineers protect systems from cyber threats, designing hardware and software to keep data safe. VLSI experts cram billions of transistors onto chips, while robotics engineers make machines sense and act. Each path demands a unique skill set, but all rely on blending hardware and software mastery. Find your passion and dive deep. We've explored the theoretical foundations, but where does all this theory actually show up in our daily lives? Where can we see the practical applications of these complex concepts? Everywhere. Look around you. The digital world is not just a concept, it's the reality we inhabit. Take cars. Modern vehicles are rolling networks of computers. They're not just modes of transportation, they're sophisticated systems on wheels. Anti-lock brakes, embedded systems reacting in milliseconds to keep you safe, preventing skids and maintaining control. These systems are a testament to real-time computing. Your smartphone is a marvel of hardware and software, a pocket-sized powerhouse connecting you to the world. From custom chips, designed for optimal performance and energy efficiency, to secure operating systems, protecting your data and privacy in an increasingly connected world. Data centers powering Google and Netflix, the backbone of the internet, enabling seamless streaming and instant access to information. Computer engineers design the servers, optimizing their architecture for speed, reliability, and scalability, and software that keep them running 24/7, ensuring uninterrupted service and data availability. Even medicine relies on computer engineering. MRI machines use custom hardware and algorithms, pushing the boundaries of medical imaging technology to create life-saving images, providing doctors with critical insights for diagnosis and treatment. Every breakthrough, from streaming movies, delivering entertainment to millions, to diagnosing disease, improving healthcare outcomes and saving lives, is built on computer engineering. It's the invisible force driving innovation across countless industries. It's about turning abstract ideas into real-world impact. It's about solving complex problems and creating solutions that benefit society. The world runs on what computer engineers create. They are the architects of the digital age. Every device, every connection, every innovation, there's a computer engineer behind it. They are the unsung heroes of the modern world. That's the power of this field. It's a field that shapes the future. Inspired? Start building. Grab a Raspberry Pi or Arduino and make something. Fail, learn, repeat. Embrace math and science. They're the foundation for everything you'll build. Learn to code. Start with Python, then tackle C or C++ to get closer to the hardware. This dual fluency is what sets computer engineers apart. Stay curious. Tech evolves fast, so learn how to learn. Join clubs, contribute to open source, surround yourself with passionate people. The future is unwritten. Go build it.